Hello class, in this video I'm going to demonstrate how to calculate the price of a bond when the market rate of interest is different from the stated rate. Now to do that I'm going to use a spreadsheet I've prepared. So let me take off my video right here so you can see the spreadsheet. And as an example I'm going to use exercise E93 in the third edition of your textbook. Also we'll need to use the present value tables on pages P1 through P4 in the textbook. And so look in the very back of the textbook and you'll find those present value tables. In this example, the bond face value is $41 million. The stated rate of interest for the bond is 9%. The term of the bonds, 20 years. So the first step we take is to convert the years into 6-month interest payment periods. So 20 years will equal 40 6-month interest payment periods. The next step is to compute the cash payment for the interest that will be paid every 6 months. To calculate that, we always take the bond face value times the stated interest rate, which is 9%, times 1/2 year. 6 months will be 1/2 year. So every 6 months, the cash payment for the interest will be $1,845,000. In a few minutes, when we go to the tables to find the present value factors to use, we need to use then 40 periods for the interest payment periods, and the interest rate we're going to look up on the table will be half of the market rate of interest. In part 1 of the exercise, they tell us that the market rate of interest is 8%. Remember that the stated rate of interest for the bond is 9%. So we have a market rate of 8% and a stated rate of 9%. So we're going to use 40 periods to look up in the table, and we'll use 4%, which is half of the market rate of interest, to look that up on the table. You can see along here I have the problem already solved. What I'm going to do is remove these factors and show you where I get these. Take those out. So now we don't have either of these numbers, the results yet. What we need to do is calculate the present value of the face value. So we're going to take $41 million times a certain factor from the table. Then we need to find the present value of all the interest payments. Each 6-month period, we will pay $1,845,000 in interest. Go to your Connect account, go to the home page, look at the library and the ebook. It's going to load just a second. We're going to get to the present value tables that are in the back of the book. So let's go to the end matter if you're looking at the text online. The end matter sections, go to the future present value tables. Okay, so here they are. These are the same present value tables and future value tables that are in the back of your textbooks if you have a paper copy of your textbook. I know on this screen here they're awful small, the numbers are awful small, very difficult to read. So if you have your paper copy of the textbook, go back to the back and find the tables and follow along as I go through these examples. Going back to the spreadsheet, we need to find the present value of the face value, which is one payment out in the future. So 20 years or 40 interest payment periods later, then $41 million will be paid back to the bond buyer, back to the investor. We need table 2 for this. So pick up table 2, and here's table 2. It's the present value of a dollar table. From this table, we will go down the 4%, that's half the market rate of interest, 4% column until we find 40 periods. And this is difficult to read, but that's 0.20829. Enter that factor on the spreadsheet. It's 0.20829. Hit enter, And what we just found is today's value, the present value of $41 million, 40 6-month periods out in the future, discounted at a rate of 4%. So that's the present value of that one lump sum $41 million payment. The next thing we need to do is find the factor for the payments that are made every 6 months. And an even payment in even time periods are called annuities. So we'll need to go to a different table. So back to your tables, we will need table number 4, present value of an ordinary annuity of $1. We use the same number of periods and the same percent. And so on table 4, the 4% column, 40 period row, the factor, it's very difficult to read, but it's 19.79277. Let's take that factor, enter it in the worksheet. So 19.79277 and hit enter. This gives us the present value of $41,845 payments. So each 6-month period, we're paying $1,845,000. And there's the factor, that's the present value of all those future interest payments. We add the present value of the lump sum face value. We add the present value of the interest payments to get the bond price today of $45,057,551. This bond price that we came up with will be a little bit different depending on if you use your own calculator to calculate this, if you use Excel, if you have a different set of present value tables that don't round out as much, that don't take it out like 4 decimal places or take it out more than 4 decimal places, this will be off. I did a quick calculation in Excel to find the price of the bond, and I used Excel functions, present value functions, and I came up with $45,057,519. So we're within about $30 of this original answer. So if you get close like this, you know you've probably done it correctly. So don't worry about small differences. So that's how to find the price of the bond. Again, you need to find the present value of the face value and the present value of all the future interest payments. And that will give you how much the price of the bond is today.